The Ring of Fire is an area where a large number of earthquakes and volcanic eruptions occur in the basin of the Pacific Ocean. In a 40,000 km horseshoe shape, it is associated with a nearly continuous series of oceanic trenches, volcanic arcs, and volcanic belts and/or plate movements. It has 452 volcanoes and is home to over 75% of the world's active and dormant volcanoes. It is sometimes called the Circum-Pacific Belt or the Circum-Pacific Seismic Belt. About 90% of the world's earthquakes and 81% of the world's largest earthquakes occur along the Ring of Fire. The next most seismically active region is the Alpide Belt, which extends from Java to Sumatra through the Himalayas, the Mediterranean, and out into the Atlantic. The Mid-Atlantic Ridge is the third most prominent earthquake belt. The Ring of Fire is a direct result of plate tectonics and the movement and collisions of lithospheric plates. The eastern section of the ring is the result of the Nazca Plate and the Cocos Plate being subducted beneath the westward moving South American Plate. The Cocos Plate is being subducted beneath the Caribbean Plate, in Central America. A portion of the Pacific Plate along with a small Juan de Fuca Plate are being subducted beneath the North American Plate. Along the northern portion, the northwestward moving Pacific Plate is being subducted beneath the Aleutian Islands Arc. Farther west, the Pacific Plate is being subducted along the Kamchatka Peninsula arcs on south past Japan. The southern portion is more complex, with a number of smaller tectonic plates in collision with the Pacific Plate from the Mariana Islands, the Philippines, Bougainville, Tonga, and New Zealand. This portion excludes Australia, since it lies in the center of its tectonic plate. Indonesia lies between the Ring of Fire along the northeastern islands adjacent to and including New Guinea and the Alpide Belt along the south and west from Sumatra, Java, Bali, Flores, and Timor. The famous and very active San Andreas Fault Zone of California is a transform fault which offsets a portion of the East Pacific Rise under southwestern United States and Mexico. The motion of the fault generates numerous small earthquakes, at multiple times a day, most of which are too small to be felt. The active Queen Charlotte Fault on the west coast of the Haida Gwaii, British Columbia, Canada, has generated 3 large earthquakes during the 20th century, a magnitude 7 event in 1929, a magnitude 8.1 in 1949, and a magnitude 7.4 in 1970. Andes. Chile. Earthquake activity in Chile is related to subduction of the Nazca Plate to the east. Chile notably holds the record for the largest earthquake ever recorded, the 1960 Valdivia earthquake. Villarrica, one of Chile's most active volcanoes, rises above Villarrica Lake and the town of Villarrica. It is the westernmost of 3 large stratovolcanoes that trend perpendicular to the Andean chain. A 6-kilometer-wide caldera formed during the late Pleistocene, 0.9 million years ago. A 2-kilometer-wide postglacial caldera is located at the base of the presently active, dominantly basaltic to andesitic cone at the NW margin of the Pleistocene caldera. About 25 scoria cones dot Villarrica's flanks. Plinian eruptions and pyroclastic flows have been produced during the Holocene from this dominantly basaltic volcano, but historical eruptions have consisted of largely mild to moderate explosive activity with occasional lava fusion. Lahars from the glacier-covered volcanoes have damaged towns on its flanks. Chile has experienced numerous volcanic eruptions from 60 volcanoes, including Lema volcano and the Chaitauquapiritén volcano. More recently, an 8.8 magnitude earthquake struck central Chile on February 27, 2010. The Pujucorda-Cubdencal volcano erupted in 2011 and an 8.2 magnitude earthquake struck northern Chile on April 1, 2014. The main shock was preceded by a number of moderate to large shocks and was followed by a large number of moderate to very large aftershocks, including an M7.6 event on April 3. Bolivia. The country of Bolivia hosts numerous active and extinct volcanoes across its territory. The active volcanoes are located in western Bolivia where they make up the Cordillera Occidental, the western limit of the Altiplano Plateau. Many of the active volcanoes are international mountains shared with Chile. All Cenozoic volcanoes of Bolivia are part of the central volcanic zone of the Andean volcanic belt that results due to processes involved in the subduction of the Nazca Plate under the South American Plate. The central volcanic zone is a major Upper Cenozoic volcanic province. Apart from Andean volcanoes, the geology of Bolivia hosts the remnants of ancient volcanoes around the Precambrian Guapora copyright shield in the eastern part of the country. Central America. Costa Rica, a powerful, magnitude 7.6 earthquake shook Costa Rica and a wide swathe of Central America at 8:42 a.m. on 09/2012. North American Cordillera, Mexico. Volcanoes of Mexico are related to subduction of the Cocos and Rivera plates to the east, subduction which has produced large explosive eruptions. Most active volcanoes in Mexico occur in the Trans-Mexican Volcanic Belt, which extends 900 kilometers from west to east across central southern Mexico. A few other active volcanoes in northern Mexico are related to extensional tectonics of the Basin and Range Province, which splits the Baja California Peninsula from the mainland. Popocatépetl, lying in the eastern half of the Trans-Mexican Volcanic Belt, is the second highest peak in Mexico after the Pico de Orizaba. It is one of the most active volcanoes in Mexico, having had more than 20 major eruptions since the arrival of the Spanish in 1519. The 1982 eruption of El Chichiquiden, which killed about 2,000 people who lived near the volcano, created a 1-kilometer-wide caldera that filled with an acidic crater lake. Prior to 2000, this relatively unknown volcano was heavily forested and of no greater height than adjacent non-volcanic peaks. United States. In the western United States lies the Cascade Volcanic Arcade. It includes nearly 20 major volcanoes, among a total of over 4,000 separate volcanic vents including numerous stratovolcanoes, shield volcanoes, lava domes, and cinder cones, along with a few isolated examples of rarer volcanic forms such as tuffs. Volcanism in the Arc began about 37 million years ago, however, most of the present-day Cascade volcanoes are less than 2 million years old, and the highest peaks are less than 100,000 years old. The arc formed by the subduction of the Gorda and Juan de Fuca plates at the Cascadia subduction zone. This is a 680 mi long fault, running 50 mi off the west coast of the Pacific Northwest from Northern California to Vancouver Island, British Columbia. The plates move at a relative rate of over 0.40 inches per year at a somewhat oblique angle to the subduction zone. Because of the very large fault area, the Cascadia subduction zone can produce very large earthquakes, magnitude 9.0 or greater, if rupture occurred over its whole area. When the locked zone stores energy for an earthquake, the transition zone, although somewhat plastic, can rupture. Thermal and deformation studies indicate that the locked zone is fully locked for 60 km down dip from the deformation front. Further down dip, there is a transition from fully locked to aseismic sliding. Unlike most subduction zones worldwide, there is no oceanic trench present along the continental margin in Cascadia. Instead, terranes and the accretionary wedge have been uplifted to form a series of coast ranges and exotic mountains. A high rate of sedimentation from the outflow of the three major rivers which cross the Cascade Range contributes to further obscuring the presence of a trench. However, in common with most other subduction zones, the outer margin is slowly being compressed, similar to a giant spring. When the stored energy is suddenly released by slippage across the fault at irregular intervals, the Cascadia subduction zone can create very large earthquakes such as the magnitude 9 Cascadia earthquake of 1700. Geological evidence indicates that great earthquakes may have occurred at least 7 times in the last 3,500 years, suggesting a return time of 400 to 600 years. There is also evidence of accompanying tsunamis with every earthquake, as the prime reason they know of these earthquakes is through scars the tsunami left on the coast, and through Japanese records. The 1980 eruption of Mount St. Helens was the most significant to occur in the contiguous 48 U.S. states in recorded history, exceeding the destructive power and volume of material released by the 1915 eruption of California's Lassen Peak. The eruption was preceded by a 2-month series of earthquakes and steam venting episodes caused by an injection of magma at shallow depth below the mountain that created a huge bulge and a fracture system on Mount St. Helens north slope. An earthquake at 8:32 a.m. on May 18, 1980, caused the entire weakened north face to slide away, suddenly exposing the partly molten, gas and steam-rich rock in the volcano to lower pressure. The rock responded by exploding into a very hot mix of pulverized lava and older rock that sped towards Spirit Lake so fast that it quickly passed the avalanching north face. Alaska is known for its seismic and volcanic activity, holding the record for the second-largest earthquake in the world, the Good Friday earthquake, and having more than 50 volcanoes which have erupted since about 1760. Volcanoes can be found not only in the mainland but also in the Aleutian Islands. The most recent activity in the American portion of the Ring of Fire occurred in early 2009 when Mount Redoubt in Alaska became active and finally erupted late in the evening of March 22. The eruption ended in May 2009. Canada. British Columbia and Yukon are home to a vast region of volcanoes and volcanic activity in the Pacific Ring of Fire. Several mountains that many British Columbians look at every day are dormant volcanoes. Most of them erupted during the Pleistocene and Holocene. Although none of Canada's volcanoes are currently erupting, several volcanoes, volcanic fields and volcanic centers are considered potentially active. There are hot springs at some volcanoes, while 10 volcanoes in British Columbia appear related to seismic activity since 1975, including the Silver Throne Caldera, Mount Meager, Wells Grey Clearwater Volcanic Field, Mount Garibaldi, Mount Cayley, Castle Rock, the volcano, Mount Edziza, Hoodoo Mountain, Crow Lagoon and Natsko Cone. The volcanoes are grouped into 5 volcanic belts with different tectonic settings. The Northern Cordilleran Volcanic Province is the most active volcanic region in Canada. It formed due to extensional cracking, faulting and rifting of the North American Plate, as the Pacific Plate grinds and slides past the Queen Charlotte Fault, unlike subduction that produces the volcanoes in Japan, Philippines and Indonesia. The region has Canada's largest volcanoes, much larger than the minor stratovolcanoes found in the Canadian portion of the Cascade Volcanic Arcade. Several eruptions are known to have occurred within the last 400 years. Mount Edziza is a huge volcanic complex that erupted several times in the past several thousand years and has formed several cinder cones and lava flows. The complex comprises the Mount Edziza Plateau, a large volcanic plateau made of predominantly basaltic lava flows with 4 large stratovolcanoes built on top of the plateau. The associated lava domes and satellite cones were constructed over the past 7.5 million years during 5 magmatic cycles beginning with eruption of alkali basalts and ending with felsic and basaltic eruptions as late as 1,340 years ago. The blocky lava flows still maintain their original forms. Hoodoo Mountain is a tufa in northwestern British Columbia, which has had several periods of subglacial eruptions. The oldest eruptions occurred about 100,000 years ago and the most recent about 7,000 years ago. Hoodoo Mountain is also considered active and could erupt in the future. The nearby Tsegs Cone and the volcano produced some of Canada's youngest lava flows, that are about 150 years old. Canada's worst-known geophysical disaster came from the Tsegs Cone during the 18th century at the southernmost end of the volcanic belt. The eruption produced a 22.5 km long lava flow, destroying the Niskayah villages and the death of at least 2,000 Niskayah people by volcanic gases and poisonous smoke. The Nass River Valley was inundated by the lava flows and contains abundant tree molds and lava tubes. The event happened at the same time with the arrival of the first European explorers to penetrate the uncharted coastal waters of northern British Columbia. Today, the basaltic lava deposits are a draw to tourists and are part of the Niskayah Memorial Lava Beds Provincial Park. The Garibaldi Volcanic Belt in southwestern British Columbia is the northern extension of the Cascade Volcanic Arcade in the United States and contains the most explosive young volcanoes in Canada. It formed as a result of subduction of the Juan de Fuca Plate under the North American Plate along the Cascadia subduction zone. The Garibaldi Volcanic Belt includes the Bridge River Cones, Mount Cayley, Mount Phi, Mount Garibaldi, Mount Price, Mount Meager, the Squamish Volcanic Field and much more smaller volcanoes. The eruption styles in the belt range from effusive to explosive, with compositions from basalt to rhyolite. Morphologically, centers include calderas, cinder cones, stratovolcanoes and small isolated lava masses. Due to repeated continental and alpine glaciations, many of the volcanic deposits in the belt reflect complex interactions between magma composition, topography, and changing ice configurations. The most recent major catastrophic eruption in the Garibaldi volcanic belt was the 2350 BP eruption of Mount Meager. It was similar to the 1980 eruption of Mount St. Helens, sending an ash column approximately 20 km high into the stratosphere. The Chilcotin Group is a north-south range of volcanoes in southern British Columbia running parallel to the Garibaldi volcanic belt. The majority of the eruptions in this belt happened either 6–10 million years ago or 2–3 million years ago, although there have been some slightly more recent eruptions. It is thought to have formed as a result of back arc extension behind the Cascadia subduction zone. Volcanoes in this belt include Mount Noel, the Kalispiko caldera complex, Lightning Peak, Black Dome Mountain and many lava flows. The Anaheim Volcanic Belt is a line of volcanoes stretching from just north of Vancouver Island to near Quesnel, British Columbia, Canada. These volcanoes were formed 8 to 1 million years ago, and the Nazca Cone last erupted only 7,200 years ago. The volcanoes generally get younger as one moves from the coast to the interior. These volcanoes are thought to have formed as a result of the North American plate sliding westward over a small hotspot, called the Anaheim Hotspot. The hotspot is considered similar to the one feeding the Hawaiian Islands. The belt is defined by 3 large shield volcanoes and 37 quaternary basalt centers. Eruptions of basaltic to rhyolitic volcanoes and hypabyssal rocks of the Alert Bay volcanic belt in northern Vancouver Island are probably linked with the subducted margin flanked by the Explorer and Juan de Fuca plates at the Cascadia subduction zone. It appears to have been active during the Pliocene and Pleistocene time. However, no Holocene eruptions are known, and volcanic activity in the belt has likely ceased. Russia. The Kamchatka Peninsula in the Russian Far East is one of the most various and active volcanic areas in the world, with an area of 472,300 km². It lies between the Pacific Ocean to the east and the Okhotsk Sea to the west. Immediately offshore along the Pacific coast of the peninsula runs the 10,500-meter deep Kuril-Kamchatka Trench. This is where rapid subduction of the Pacific plate fuels the intense volcanism. Almost all types of volcanic activity are present, from stratovolcanoes and shield volcanoes to Hawaiian-style fissure eruptions. There are over 30 active volcanoes and hundreds of dormant and extinct volcanoes in 2 major volcanic belts. The most recent activity takes place in the eastern belt, starting in the north at the Shevelich Volcanic Complex, which lies at the junction of the Aleutian and Kamchatka volcanic arcs. Just to the south is the famous Klyuchi Volcanic Group, comprising the twin volcanic cones of Klyuchevskoy and Kármán, the huge volcanic complexes of Tolbachik and Ushkovsky, and a number of other large stratovolcanoes. The only active volcano in the central belt is found west of here, the huge remote Ikinsky. Further south, the eastern belt continues to the southern slope of Kamchatka, topped by loads of stratovolcanoes. Japan. Approximately 10% of the world's active volcanoes are found in Japan, which lies in a zone of extreme crustal instability. They are formed by subduction of the Pacific Plate and the Philippine Sea Plate. As many as 1,500 earthquakes are recorded yearly, and magnitudes of 4 to 6 on the Richter scale are not uncommon. Minor tremors occur almost daily in one part of the country or another, causing some slight shaking of buildings. Major earthquakes occur infrequently. The most famous in the 20th century were, the Great Kanto earthquake of 1923, in which 130,000 people died, and the Great Hanshin earthquake of January 17, 1995, in which 6,434 people died. On March 11, 2011 a magnitude 9.0 earthquake hit Japan, the country's biggest ever and the fifth largest on record, according to U.S. Geological Survey data. Undersea earthquakes also expose the Japanese coastline to danger from tsunamis. Mount Bandai, one of Japan's most noted volcanoes, rises above the north shore of Lake Inawashiro. Mount Bandai is formed of several overlapping stratovolcanoes, the largest of which is Obandai, forming a complex volcano. Obandai volcano was constructed within a horseshoe-shaped caldera that formed about 40,000 years when an earlier volcano collapsed, forming the Okinoshima debris avalanche, which traveled to the southwest and was accompanied by a Plinian eruption. 4 major phreatic eruptions have occurred during the past 5,000 years, 2 of them in historical time, in 806 and 1888. Seen from the south, Bandai presents a conical profile, but much of the north side of the volcano is missing as a result of the collapse of Koh-Bandai volcano during the 1888 eruption, in which a debris avalanche buried several villages and formed several large lakes. Nearly a century ago, the north flank of Mount Bandai collapsed during an eruption quite similar to the May 18, 1980 eruption of Mount St. Helens. After a week of seismic activity, a large earthquake on July 15, 1888, was followed by a tremendous noise and a large explosion. Eyewitnesses heard about 15 to 20 additional explosions and observed that the last one was projected almost horizontally to the north. Mount Fuji is Japan's highest and most noted volcano. The modern Pustler-Shell stratovolcano is constructed above a group of overlapping volcanoes, remnants of which form irregularities on Fuji's profile. Growth of the younger Mount Fuji began with a period of voluminous lava flows from 11,000 to 8,000 years ago, accounting for 4/5 of the volume of the younger Mount Fuji. Minor explosive eruptions dominated activity from 8,000 to 4,500 years ago, with another period of major lava flows occurring from 4,500 to 3,000 years ago. Subsequently, intermittent major explosive eruptions occurred, with subordinate lava flows and small pyroclastic flows. Summit eruptions dominated from 3,000 to 2,000 years ago, after which flank vents were active. The extensive basaltic lava flows from the summit and some of the more than 100 flank cones and vents block drainages against the tertiary Misaka Mountains on the north side of the volcano, forming the Fuji Five Lakes. The last eruption of this dominantly basaltic volcano in 1707 ejected andesitic pumice and formed a large new crater on the east flank. Scientists are saying that there may be some minor volcanic activity in the next few years. Philippines. The 1991 eruption of Mount Pinatubo is the world's second largest terrestrial eruption of the 20th century. Successful predictions of the onset of the climactic eruption led to the evacuation of tens of thousands of people from the surrounding areas, saving many lives, but as the surrounding areas were severely damaged by pyroclastic flows, ash deposits, and later, lahars caused by rainwater remobilizing earlier volcanic deposits, thousands of houses were destroyed. Mayon volcano is the Philippines' most active volcano. The volcano has steep upper slopes that average 35°-40 degrees and is capped by a small summit crater. The historical eruptions of this basaltic andesitic volcano dates back to 1616 and ranges from Strombolian to basaltic Plinian eruptions. Eruptions occur predominantly from the central conduit and have also produced lava flows that travel far down the flanks. Pyroclastic flows and mud flows have commonly swept down many of the approximately 40 ravines that radiate from the summit and have often devastated populated lowland areas. Taal volcano has had 33 recorded eruptions since 1572. A devastating eruption occurred in 1911, which claimed more than 1,000 lives. The deposits of that eruption consist of a yellowish, fairly decomposed tufa with a high sulfur content. The most recent period of activity lasted from 1965 to 1977, and was characterized by the interaction of magma with the lake water, which produced violent phreatic and phytomagmatic eruptions. Although the volcano has been dormant since 1977, it has shown signs of unrest since 1991, with strong seismic activity and ground fracturing events, as well as the formation of small mud geysers on parts of the island. Canlaon volcano is the most active volcano in central Philippines and has erupted 25 times since 1866. Eruptions are typically phreatic explosions of small to moderate size that produce minor ashfalls near the volcano. On August 10, 1996, Canlaon erupted without warning, killing British student Julian Green and Filipinos Noel Tragico and Neil Perez, who were among 24 mountain climbers who were trapped near the summit. Indonesia. The volcanoes in Indonesia are among the most active of the Pacific Ring of Fire. They are formed due to subduction zones of three main active tectonic plates, namely the Eurasian Plate, Pacific Plate, and the Indo-Australian Plate. Some of the volcanoes are notable for their eruptions, for instance, Krakatau for its global effects in 1883, Lake Toba for its supravolcanic eruption estimated to have occurred 74,000 BP, which was responsible for 6 years of volcanic winter, and Mount Tambora for the most violent eruption in recorded history in 1815. The eruption of Mount Tambora in 1815 caused widespread harvest failures in northern Europe, the northeastern United States, and eastern Canada in 1816, which was known as the Year Without a Summer. The most active volcanoes are Kelad and Mount Merapi on Java Island, which have been responsible for thousands of deaths in the region. Since AD 1000, Kelad has erupted more than 30 times, of which the largest eruption was at scale 5 on the Volcanic Explosivity Index, while Merapi has erupted more than 80 times. The International Association of Volcanology and Chemistry of the Earth's interior has named Merapi as a decade volcano since 1995 because of its high volcanic activity. New Zealand. New Zealand contains the world's strongest concentration of youthful rhyolitic volcanoes, and voluminous sheets blanket much of the North Island. The earliest historically dated eruption was at Waikari White Island in 1826, followed in 1886, by the country's largest historical eruption at Mount Taurora. Much of the region north of New Zealand's North Island is made up of seamounts and small islands, including 16 submarine volcanoes. In the last 1.6 million years, most of New Zealand's volcanism is from the Taupo volcanic zone. Mount Ruapehu at the southern end of the Taupo volcanic zone, is one of the most active volcanoes. It began erupting at least 250,000 years ago. In recorded history, major eruptions have been about 50 years apart, in 1895, 1945 and 1995 1996. Minor eruptions are frequent, with at least 60 since 1945. Some of the minor eruptions in the 1970s generated small ash falls and lahars that damaged skyfields. Between major eruptions, a warm acidic crater lake forms, fed by melting snow. Major eruptions may completely expel the lake water. Where a major eruption has deposited a tephra dam across the lake's outlet, the dam may collapse after the lake has refilled and risen above the level of its normal outlet, the outrush of water causing a large lahar. The most notable lahar caused the Tangiwai disaster in December 1953, when 151 people aboard a Wellington to Auckland Express train were killed after the lahar destroyed the Tangiwai rail bridge just moments before the train was due. In 2000, the ALAWS system was installed on the mountain to detect such a collapse and alert the relevant authorities. The Auckland volcanic field on the North Island of New Zealand has produced a diverse array of explosive craters, scoria cones, and lava flows. Currently dormant, the field is likely to erupt again within the next hundreds to thousands of years, a very short time frame in geologic terms. The field contains at least 40 volcanoes, most recently active about 600 years ago at Rangitoto Island, erupting 2.3 cubic kilometers of lava. Antarctica. The Pacific Ring of Fire is completed in the south by the continent of Antarctica, which includes many large volcanoes. The makeup and structure of the volcanoes in Antarctica change largely from the other places around the ring. In contrast, the Antarctic plate is almost completely surrounded by extensional zones, with several mid-ocean ridges which encircle it, and there is only a small subduction zone at the tip of the Antarctic Peninsula, reaching eastward to the remote South Sandwich Islands. The most well-known volcano in Antarctica is Mount Erebus, which is also the world's southernmost active volcano. In many respects the geology of the Antarctic Peninsula is an extension of the Andes, hence the name sometimes used by geologists, Antarctans. At the opposite side of the continent, the volcanoes of Victoria Land may be seen as the other end of the Antarctans, thus completing the Pacific Ring of Fire and continuing up through the Balleny Islands to New Zealand. The volcanoes of the Victoria Land area are the most well-known in Antarctica, most likely because they are the most accessible. Much of Victoria Land is mountainous, developing the eastern section of the Transantarctic Mountains, and there are several scattered volcanoes including Mount Overlord and Mount Melbourne in the northern part. Further south are two more well-known volcanoes, Mount Discovery and Mount Morning, which are on the coast across from Mount Erebus and Mount Terror on Ross Island. The volcanism in this area is caused by rifting along a number of rift zones increasing mainly north-south similar to the coast. Marie Byrd Land contains the largest volcanic region in Antarctica, covering a length of almost 600 miles along the Pacific coast. The volcanism is the result of rifting along the vast West Antarctic Rift, which extends from the base of the Antarctic Peninsula to the surrounding area of Ross Island, and the volcanoes are found along the northern edge of the rift. Protruding up through the ice are a large number of major shield volcanoes, including Mount Sidley, which is the highest volcano in Antarctica. Although a number of the volcanoes are relatively young and are potentially active, others such as Mount Andros and Mount Hampton are over 10 million years old, yet maintain uneroded constructional forms. The desert-like surroundings of the Antarctic interior, along with a very thick and stable ice sheet which encloses and protects the bases of the volcanoes, which decreases the speed of erosion by an issue of perhaps 1,000 relative to volcanoes in moist temperate or tropical climates. Land areas. See also. References. External links, Historic earthquakes and earthquake statistics at the United States Geological Survey, description, Ring of Fire, plate tectonics, sea floor spreading, subduction zones, hotspots at the USGS Cascades Volcano Observatory, Vancouver, Washington website. Map of the Ring of Fire, tectonic activity, the Ring of Fire at work, Physical World Map April 1, 2004 CIA World Factbook. Robinson projection. Standard parallels 38°N and 38°S.